Okay, so when we're trying to find the horizontal asymptotes, you do have to take the limit from as you approach negative infinity and as you approach infinity. So usually these are the same thing, but in some situations, like when you have a square root, it's often different than normal ones. So here, you know how like as x gets really big, these small terms don't really matter as much? So you can kind of like not worry about them, and you're really just worrying about the leading terms. So when you take the square root of 4x squared, you get 2x. But because it wasn't the square root, it has to be positive. So I'm just going to put it in absolute values. And then the denominator is 2x. So as you plug in large negative numbers into this, the top will always be positive and the bottom will be negative if you plug in a negative number. So because of that, this approaches -1. But if you plug in a large positive number, well, now the numerator is positive and the denominator is positive, so that's why this one is 1. So this is one of those weird situations where you have two different horizontal asymptotes. So let me give you another example. Like, let's say you have, is that still on the screen? Okay. Let's say you have the limit, or let's say you have another function. All right, so now this is another situation where we'd want to find the horizontal asymptote. So we're going to take the limit as x approaches negative infinity of the function. So here, do you see like how there's no square root? So when you plug in a big negative number, both the numerator and the denominator will be negative. So the negatives will cancel. So you just have to take the ratio of the coefficients, 2/14 or 1/7. And then you take the limit as x approaches positive infinity. And now you're plugging in large positive numbers, so there's no negatives at all. And then you just get 1/7. So here are the two horizontal asymptotes agree. Hope that helps. If any more questions, let me know. Thanks.